We'll talk about homogeneous differential equation. The first thing we will discuss about homogeneous function. So this is the basic idea to define homogeneous differential equation. First we will talk about homogeneous function, and later we will discuss about homogeneous differential equation, and and afterwards we will discuss the procedure for how to solve a homogeneous first order differential equation. Let's begin with homogeneous function. A function fxy is said to be a homogeneous function in variables x and y of degree n if the given function could be expressed like this: f of kx comma ky, which is equals to k power n f of x comma y for all values of k where n is any constant. This is the definition of the homogeneous function. So sometime, okay, every function, so not possible to express f of kx comma ky equal to k power n f of xy. In such cases, we can adopt another technique to define or to know the function is homogeneous or not. So a function of degree n in x and y can also be expressed like this: y to the power of n f of x by y, which means every term in the function in the form of like x by y. Outside is y to the power of n, which means from the function, let us, okay, we will take y power n outside and make the remaining part as a function of xy, or else sometime, so you can take x to the power of n, so times a function of y by x. So it all depends upon given function. Now let's define homogeneous differential equation. So our differential equation dy by dx equal to f of xy. It's a first order with first degree differential equation. Okay, is said to be homogeneous differential equation in variables x and y. It should satisfy, which means this function f of xy is a homogeneous function of degree 0. I repeat again, this differential equation is said to be homogeneous differential equation. The criteria is the right side function f of xy is a homogeneous function of degree 0. So for example, here there are examples given. So x square times y dx minus of x cube plus y cube dy equal to 0. This is a homogeneous differential equation. If you observe here, first term degree is 3, and even here in the second term, each term degree is 3. Anyhow, if you write in standard form like dy by dx equal to f of xy, definitely it should be a homogeneous function of degree 0, which means this differential equation is said to be homogeneous differential equation. Similarly here, dy by dx equal to this right side quantity is a function of x comma y. So this is also here every term degree in numerator as well as in denominator, degree of each term is 2. So anyhow, this could be writing like k to the power of 0 times f of xy, which means 0 degree homogeneous function. Now, so let's begin the procedure how to solve, or working rule how to solve this first order homogeneous differential equation. The very first step is here. So substitute y equal to vx in the given equation, changing y equal to vx, and differentiate this y equal to vx both side with respect to x, you will get dy by dx. So applying here product rule of derivative, so apply v plus, so derivative of x is 1 plus x times derivative of v with respect to x is dv by dx. Okay, so here we need to substitute y value as well as derivative value in the given equation, differential equation, that will be reduced in the variables x and v or v and x. Once the equation reduced in v and x, so we can adopt here variable separable method, and we will solve the equation by using variable separable method, and later on at the end of the solution we will substitute v equal to y by x. We get the required general solution of the given homogeneous differential equation. Let's solve one of, okay, previous example only I'll take here. This example I'll solve x square y times dx minus of x cube plus y cube dy equals to 0. Finding general solution of this equation. So let us take the question. Question is, say question number 1. So solve x square times y dx minus of x cube plus y cube dy equal to 0. dy equal to 0. This could be rewriting in standard form like x square y dx equals to x cube plus y cube times dy. Just transpose this one to right side, this term. So again rearrange dy by dx equals to x square y will be in numerator divided by denominator x cube plus y cube. Let us say it is equation number 1. Just shuffle the terms in such a way. So dy by dx will become x square y divided by x cube plus y cube. Here this right side function, since I can say here f of xy means this right side function, this quantity. This quantity is called f of x comma y. So f of xy equal to x square times y over x cube plus y cube. Clearly it seems homogeneous function of degree 0. How means f of kx comma, it is optional to complete in examination point of view, but so you need to check the given function is homogeneous or not. Afterwards only we can adopt the technique. F of kx comma ky equal to, so I will be writing here x square means k square x square. You just plug in here x place kx. So you will get here k square x square. Again we have y, that is k times y over. So again x cube is there. X means kx. Means k power 3. We can say x power 3. Again plus k power 3 y power 3. So after that let us take from numerator. Means here just multiply. This k square times k is k power 3. So times x square y I am writing together divided by here k cube is a common term in denominator. Let us take k cube outside, left with x cube plus y cube. So anyhow k power 3 again k power 3 cancel out. It is nothing but k power 0 times f of, again you will get back same function. This is x square y divided by x cube plus y cube is nothing but given function only. So means here k power 0 f of xy, which means this function is a homogeneous function with a degree 0. Then we can say one is a, therefore one is a homogeneous differential equation. Homogeneous, we can say homogeneous differential equation. Okay, because of the function is a homogeneous function with degree 0. This is the idea. After that the substitution is to proceed for solution. Put y equal to vx and dy by dx. How you will get dy by dx means just differentiating both sides with respect to x. V plus x times dv by dx in equation number 1. Substituting both in equation number 1. LHS value dy by dx, it becomes now v plus x times dv by dx, it is equal to, right side is x square, we have y means vx divided by denominator x cube same, only substitute y equal to vx, which means we have y cube, which means vx whole cube together. Just substitution of here, y means vx, here also y means vx. And what about this one, dy by dx, v plus x to dv by dx, substituted left side. Now simplifying right side, how here this is same, I will keep denominator, numerator is v times x power 3 because x square times x is x power 3, and denominator x power 3 plus v power 3 times x power 3. So this is, if you open, it will become v power 3 x power 3. So next step will be v plus x times dv by dx. This is equals to, we can write v times x power 3 divided by, so here x power 3 plus v power 3 again x power 3. So after that v plus x times dv by dx, this is equals to v times x power 3 over, so x power 3 is common from denominator, 1 plus v power 3 will be left out part. This x power 3 cancel out. The next step, v plus x times dv by dx, this is equals to v divided by 1 plus v power 3. This could be rewriting like this next step. Just take this v to right side. So which means x times dv by dx, this is equals to v times v divided by 1 plus v power 3 minus v. If you take this v to right side, it becomes minus v. Now LCM, because here denominator, right side denominator is 1. LCM is 1 plus v power 3. The next step is x times dv by dx. This is equals to, let us take LCM of 1 plus v cube comma 1 is 1 plus v cube. Now just multiply with 1 times v is v again. Now this v is multiplied with both terms, which means v times 1 plus v power 3. Okay. Now afterwards we will simplify numerator. So left side is x times dv by dx. This is equals to, right side is v minus v to the power of 4 over 1 plus v power 3. Reason is, here if you look, v times 1 is v times v power 3 v power 4, but negative sign, because of minus times plus is minus. So I have written over there. Now these two cancel out. So I left with here x times dv by dx. This is equals to, so minus v to the power of 4 over 1 plus v to the power of 3. So now I have to be separate. So using variable separable method. How? Just let us take this whole quantity, this one to left side, because it's a function of v. I want to take left side, which means how we need to carefully here transpose to left side. How? So this 1 plus will be taking place in numerator. Okay, this v power 4, if you bring left side, it goes to denominator. dv keep left side. Again, this dx, if you take right side, it will be, okay, writing in numerator. It will be taking place in numerator. What about x? X is coming down. It is in denominator. This arrangement careful. We forgot about minus here, this minus. Either you can keep right side or left side, doesn't matter. I repeat again. So this one I have taken left. Left means numerator. This is right now in numerator. If you bring left, it will be takes place in denominator. dv same place. Again, this is in top, this is in bottom. If you shift right side, it will be takes numerator. If you shift right side, it will be takes denominator. Now clearly variables are separated. Here variables are separated. We can say variables are separated. Now what to do? We have to be perform integration. Now integrate on both sides. Integrate on both sides. Integrate on both sides. On integration, 1 plus v power 3 over v to the power of 4, it is equal to minus integration. This could be writing like 1 by x dx plus integration constant c. It depends upon, okay, function, we can write plus c or logarithmic function c. Now here we left with the dv. Now how to perform integration? This is very important role now. So integration of, I will separate here 1 plus v to the power of 4 plus v to the power of 3 divided by v to the power of 4 dv equal to, right side is 1 by x integration is ln x plus logarithmic constant c or only c. Okay, after that, how I have separated this one? So this one. So how I have separated, like 1 by v power 4 v power 3 by v power 4 means just a simple basic idea applied. So a plus b, it's a fraction. A plus b by c could be writing like a by c plus b by c. This basic rule. Apply this rule. It gets like this. It is v power 3. Now next step, this could be rewriting again v power minus 4 plus here 1 v power 3, 1 v power 3 cancel, 1 by v left, dv equal to, right side integration is completed plus c. Just continue right side function. Now v power minus 4 integration, power rule of integration, like x power n dx rule is x power n plus 1 over n plus 1 plus c. Same idea here. So v power minus 4 plus 1, okay, minus 3 divided by minus 4 plus 1 minus 3 plus, what about this term integration? 1 by v integration, like 1 by x integration, 1 by x dx is already we did right side, same idea here, ln x plus c ln x. So you can say here ln x ln v equal to, you can say here, minus ln x plus c. Now it's not the general solution. So we started with y equal to vx, substitution. Now this substitution, again from this substitution, v is equal to y by x. So substitute in above equation. Let us suppose this is equation number is 2. Let us give equation number to this one. So put y equal to y by x in equation 2. You will get here, first term left side is y value y by x to the power minus 3, okay, by 3, you can say. This minus I have written in numerator. This is v value is y by x power minus 3 kept same. So after that plus ln v means ln y by x. It is equal to, you can say here, minus ln x plus c. So we can extend one more step, or we can stop over here. We can further also simplify this step by writing ln y minus ln x. Ln x cancel out. You left with ln y equal to c. Here first term is, otherwise this could be writing one more step, minus 1 by 3, like this. So y by x to the power positive 3 plus again ln y by x. So it's a logarithmic rule, ln y minus ln x equal to, right side is minus ln x plus integration constant c. Ln x cancel out. So finally minus 1 by 3 times, so y by x to the power 3. So plus ln y equals to c, which is the general solution, we can say, which is the general solution of equation 1. This is the way of solving homogeneous differential equation. Let us quickly take one more problem. We will not put here x square plus 2 times y square by xy dy by dx. Another question. Solve question number 2 is solve dy by dx equals to x square plus 2 times y square divided by 2 times only xy. This is the differential. Let us say solution. So we have given, it's clearly seems first order homogeneous differential equation. I'm writing directly. Now let us suppose equation 1. This question itself I'm supposing equation 1. So put directly, I'm writing y equal to vx, and so dy by dx will be v plus x times dv by dx in equation number 1, because clearly it's a homogeneous function with a degree 0. I'm not writing all, directly I'm proceeding for solution. So y equal to vx and dy by dx equal to v plus x dv by dx in equation 1. Now it will become like this, LHS v plus x times dv by dx. This is equals to, right side is x square plus 2 times y value vx, which means v square x square divided by denominator x times vx. The next step, v plus x times dv by dx equals to, right side is x square common, you left with 1 plus 2 times v square over x square times v. So x square cancel out. Now the next step is, so I will be writing in the next page, x times dv by dx. This is equal to 1 plus 2 times v square divided by v, again minus v. The next step, x times dv by dx equals to, so denominator is v, means LCM is v here. So in the next, what happens, 1 multiply by with both of the terms, which means 1 plus 2 times v square minus again v times v is v power 2. Now x times dv by dx, this is equal to 1 plus v square divided by v. Again we need to apply variable separable method, which means bring this one to left side. So how do you bring, so this denominator will become numerator, this numerator will become denominator when you bring left side. Dv place same, okay, dv keep in same place. dx will be in numerator, x will be in denominator after shuffling terms. Here variables are separated clearly. Separated. Now we will go for integration, which means integration of v divided by 1 plus v square dv equal to integration of 1 by x plus, okay, 1 by x dx plus I can add here logarithmic constant c. By the, okay, result of this function I am writing here. I may get here the result is in terms of logarithmic function. That's what I have selected here, logarithmic constant. Even if you select plus c also, no problem. Okay, students, we have to integrate this quantity with respect to v. So we have this fundamental rule, integration of f dash x divided by f of x. If any function is uh, like this, any rational function like numerator function derivative, it is present in denominator. If denominator derivative is present in numerator, okay, then we can apply this rule, integration f dash x by f of x equal to ln f of x plus c, this rule. So we have to be check denominator. What is the denominator here? So we have given in denominator is 1 plus v square. Let us say this is f of v. F of v is 1 plus v square. Then, so what is f dash of v? F dash of v means differentiating 1 plus v square with respect to v. First term constant, derivative 0. V square derivative 2v. So finally 2v. But if we look in denominator, we have only v. In numerator, we have only v. Okay, in that case, what to do? I have to be multiply and divide by 2. I have to be multiply and divide by 2, which means 1 by 2 times integral. So I'm writing here 2v by 1 plus v square dv equals to right side, no problem. Integration of 1 by x is ln x plus ln c. I repeat again, here I need here 2v, f dash v value 2v, but I don't have 2v here. So I have to be multiply by 2 and the same number divide by 2. The reason is both will cancel out. Again I will get back v by 1 plus v square. For example, here I required 100 means multiply by 100 divide by 100. For example, I need here 3. So multiply by 3 divide by 3. This idea is will be helping to integrate the function very quickly. So half time. So finally this is my f dash of v, I can say. This is my f of v. So apply this rule now. Integration f dash of v by f of v equal to ln f of v. Like idea. Same idea here. You will get here ln f of v means 1 plus v square equals to, right side is we have a logarithmic rule, ln x plus ln c equal to ln x times c or c times x. We have a rule log m multiplied by n equal to log m plus log n or ln capital N. Same idea. After that again, so we have m times ln a is same as ln a to the power of m. This rule also is as we know from logarithm. So same rule we can apply. This is my m times ln a. This power become, this half become power of this function, which means the next step is ln times 1 plus v square to the power half equal to ln c times x or x times c. Now ln both side cancel. So we left with square root of 1 plus v square equal to c times x. But as we know, y equal to vx implies, so v value back substitution is y by x. Let us say it is 2. So substitute in equation number 2 v equal to y by x, which means square root of 1 plus y by x whole square equals to c times x. We can simplify further also, stop over here. It is called general solution of equation number 1.